Find the area of the parallelogram whose adjacent sides are 1, 1, -1 and 2, 1, 2, -1, 1. So area of a parallelogram can be found as of a parallelogram is equal to magnitude of A vector cross B vector. Here we are going to consider the first point as vector A. That means I will say here A vector is equal to 1 times I cap plus 1 times J cap minus 1 times K cap. And then B vector can be written as 2 times I cap minus 1 times J cap plus 1 times K cap. Now, cross product of A cross B is nothing but a determinant which is formed as I cap, J cap, K cap, and then next one will be 1, 1, -1, and then third row will be 2, -1, 1. Means the coefficients of first vector will become your second row, coefficients of second vector will become your third row. Now we will evaluate this determinant. So it becomes I cap times 1 minus of -1. So 1 minus 1 and then plus minus J cap times 1 minus or -2. It becomes plus 2 plus K cap times -1 minus 2. So that will become minus 3 times J cap minus 3 times K cap. Now the magnitude of A cross B will be nothing but squares of the coefficients. Means whatever we got the cross product, in that the coefficient squares we have to do, means -3 the square plus -3 the square, which is square root of 9 plus 9 or square root of 18, which can be written as 3 root 2 square units. So that is the solution for this particular problem. This we need to find the area of the triangle with adjacent sides 2, 3, 2 and 4, -5, 3. So area of the triangle. Area of the triangle will be half times magnitude of first vector cross second vector. So here first vector can be defined as 2 times I cap plus 3 times J cap plus 2 times K cap. And second vector defined as B, vector B, which can be written as 4 I cap minus 5 J cap plus 3 K cap. Now A cross B can be found as a determinant, and that is written as first row will be only this I cap, J cap and K cap. Second row will have the coefficients of the first vector, which is 2, 3 and 2. Third row will have the coefficients of the second vector, which is 4, -5 and 3. Now let us evaluate the determinant, which is I cap times 3 into 3, it is 9, minus of -10, it becomes plus 10, minus J cap times 2 into 3, 6, minus 4 into 2, 8. And then finally, plus K cap times 2 into -5, which is -10. 4 into 3, it is 12, and so it is -12. So this will become 19 times I cap. Minus or minus, it becomes plus 2 times J cap. And here it is -22, so -22 times K cap. Therefore, area is equal to half times magnitude of vector A cross vector B, which will be half times square root of 19 the square plus 2 square plus -22 the square. Now let us evaluate this. 19 square we get 361, and this is 4, and this is 22 square is 484. So we get 484 plus 4 plus 361. We get square root of 849 by 2 square units. That is the solution for this particular problem. Here we need to find the area of the triangle. Vertices are known, means vertex A is given as 1, 2, 3, vertex B is given as 2, -1, 1, vertex C is given as 1, 2, and -4. So for finding out the area of triangle ABC, we need to find out half times magnitude of vector AB cross vector BC. So for which we need to first find out what is AB vector. AB vector means I need to subtract from B to A and then multiply it by the relevant I cap, J cap, etc. Means 2 minus 1, this 2 minus this 1 times I cap plus minus 1 minus 2 times J cap plus 1 minus 3 times K cap, and that is equal to 1 I cap, which is I cap only, and this is minus 3 J cap, and this is minus 2 K cap. And then BC, vector BC will be, means this minus this, which means 1 minus of 2 times I cap plus 2 minus of minus 1, so it becomes 2 plus 1 times J cap plus minus 4 minus 1 times K cap, that is minus I cap plus 3 J cap minus 5 K cap. So we got now vector AB and vector BC. Now let us find out the cross product of vector AB and vector BC, which will be the determinant of, first row will have this I cap, J cap and K cap. Second row will have the coefficients of vector AB, which is 1, minus 3, minus 2. Third row will have the coefficients of vector BC, which is minus 1, 3, minus 5. That will be I cap times minus 3 into minus 5, which is plus 15. Minus 6 means it becomes plus 6. Minus J cap times minus 5 minus 2 plus K cap times 3 minus 3. So we get 21 times I cap. This is minus 7, so it becomes plus 7 J cap. Last one is 0, so we can ignore it. Therefore, area of triangle ABC will be half times magnitude of vector AB cross vector BC, and that is half times square root of 21 square plus 7 square. So that will give you 1 by 2 times 441 plus 49. That will give you square root of 490 divided by 2 square units. So that is the solution for this particular problem. This question says, show that the 4 points A, B, C, and D, whose position vectors are given as 4i cap plus 5j cap plus k cap, minus j cap minus k cap, 3i cap plus 9j cap plus 4k cap, and minus 4i cap, 4j cap plus 4k cap, respectively, are coplanar. If A, B, C, and D are coplanar, then AB cross AC cross with dot product of AD should be equal to 0. So for which first we need to find out what is vector AB. Vector AB can be found by subtracting this with this, means this vector minus this vector. So let me write that minus j cap minus k cap minus of 4 I cap plus 5 j cap plus k cap. If we do that, we get minus j cap minus k cap minus 4 I cap minus 5 j cap minus k cap. That will give us minus 4 I cap minus 6 j cap minus 2 k cap. Similarly, if we want AC vector, I need to subtract the third position vector, that is 3 I cap plus 9 j cap plus 4 k cap minus the first position vector, which is 4 I cap plus 5 j cap plus k cap. We may directly do it. 3 I cap minus 4 I cap is minus I cap. And then 9 j cap minus 5 j cap is 4 j cap. And then 4 k cap minus k cap is 3 k cap. That is our vector AC. Now, AD vector, let us find out. That will be the fourth position vector, which is minus 4 I cap, minus 4 I cap, and then plus 4j plus 4k, plus 4j plus 4k, minus of the first position vector, which is 4 I cap plus 5j cap, plus k cap. Now directly let us subtract. 4 I cap gets cancelled. 4 j cap minus 5 j cap will become minus j cap. And then 4 k cap minus k cap will become 3 k cap. Just a moment. Here it is. Oh, sorry. I think I made a mistake here. This should be minus 4i minus 4i. It becomes minus 8i. Minus 8i cap minus j cap plus 3k cap. Now we can write down AB vector cross. We need to find out AB vector dot AD vector is equal to. Now we can write the coefficients of the first vector in the first row, minus 4, minus 6, minus 2. Coefficients of the second vector in the second row, minus 1, 4, and 3, and then minus 8, minus 1, and 3. Evaluate this. Minus 4 times 12 plus 3 plus 6 times minus 3 plus 24 minus 2 times 1 plus 32. So this is 15 into minus 4, which is minus 60. This is 21 into 6. So it is 126. 33 into minus 2, it is minus 66. So the result is 0. So that is what we have to prove. Hence, we can say A, B, C, and D are coplanar. That is how this problem is proved. In this question, it is said, find the volume of the parallelopiped whose coterminal edges represented by the vectors. Vector A, which is minus 3, 7, and 5. Vector B, minus 5, 7, and minus 3. And vector C is 7, minus 2, and minus 3. Straight away, volume can be obtained for a parallelopiped, where a volume of a parallelopiped is nothing but determinant formed by these three vectors, minus 3, 7, and 5, minus 5, 7, and minus 3, 7, minus 2, and minus 3. Now let us evaluate this. Minus 3 times the 7 into minus 3, minus 21, minus 6 minus 7 times 15 plus 21 plus 5 times 10 minus 49. So that is equated to minus 3 times minus 27 minus 7 times 36 plus 5 times minus how much it is? Minus 10. And here it is 49, that is 39. Right. So now minus 3 into minus 27 is positive 81. And this is minus 252. This is 5 nines are 45, 4, 5 threes are 15, 195. Now let us calculate this. 81 minus 252 minus 195. We get minus 366. Since it is volume, we will be neglecting the negative sign. So volume will be modulus of 366 cubic units or 366 cubic units. That will be the solution for this particular problem.